Hey everyone, Dr. Phil here. I am going to try to do this little explanation before I head to lab so I can transport all of this over. So hopefully we can do this tonight in lab. Excuse me. So I wanted to really go over diffusion and osmosis. I know last week we kind of touched on gradients. So I just kind of want to make sure that we can get some visual on this. I'm checking here to make sure I'm actually recording sound, because it would really tick me off if we did all this, and I don't know. Okay, I'm not going to mess around with it. So if you see there, I have a 20% sucrose solution, 40% sucrose solution, 60% sucrose solution, and on the far right I have a beaker of just plain water. So I'm going to fill this dialysis tube with, maybe I'll see if I can fit 10 milliliters in there. So I'll just move this up to, the screen here, I'll move it up to 10, and then I could, so we all equal amount, equal weight. I could pipette it in there too, but I think I'm going to use the graduated cylinder and the funnel. So we're going to have 10 milliliters of solution in each dialysis tube. We're going to place the dialysis tube in water. And today I'll go over diffusion. So we'll go over that. So theoretically, the solution, which is the most concentrated in sucrose, should pull the majority of the water into the dialysis tubing. So tonight when I get there, if I can find beakers and a couple of scales, we can measure the weight initially, and they all should be about the same if it's 10 milliliters. And then during the lab class, we'll weigh this. So like I said, in theory, and it's never failed yet, unless the solutions were bad, the higher the concentration of sucrose, the more water it should pull in from the external environment through the dialysis tubing, which is that diffusion membrane. So I'm going to try to get on camera here and do this. I don't want to flip the camera because then I have to stop the video. And this whole iPad thing was just not what I envisioned, but it's better than my cell phone, right? So I'm going to try to get in camera here, and hopefully it's recording. So I'm not really sure. I go in, not sure if I'm on camera here. That could have gone better. So that is 10 milliliters. I'm going to dump it in here slowly. Okay, perfect. So I'm going to basically just clamp this off. All right, so I think what I will do is, I had tape. Oh, I did. I have tape. Okay, so I go in and mark that 20%. Then ideally I should really change the cylinder, but the concentration is not going to get that diluted or mixed up. Okay, it's pretty close. And you're going to read from the bottom of the meniscus, but we're not going to get that technical here. Mark this one 40%. That's pretty close. Okay. So down here. Like I said, once again, these should have the same volume, so they should weigh theoretically about the same. And then we're going to, over time, we're going to see which dialysis tubings actually pull in more water from the external environment through osmosis. And then we'll go over that gradient again tonight. And then one more I want to do with water. Should probably. Let's rinse that out. So nobody can say that wasn't pure water. Okay. So what I'm doing with this. This dialysis tube, I'm going to put pure water in, and then what I'm going to do is I'm going to drop this. Oh, okay, that could have gone better. Okay, let me try that again. So I hope this is in the camera for everyone, but so I'm going to take 10 milliliters of, why is this being so obstinate? Okay, so that should be roughly 10 milliliters of water. I'm going to actually put this into a beaker with a sucrose solution. So what should happen is the water from here should diffuse out of this bag into the surrounding environment. These are going to go into water, so the water should go from the external environment into the bag, and it should be contingent upon the osmolarity or the concentration of the sucrose, which is basically just table sugar. Okay, so I'm hoping that was on camera. That should be about 8.5 minutes, and we'll see.